Well, good evening, everybody. Welcome to Ellensburg. It is 5:49 p.m. Pacific Time, Saturday, March 28th, 2020. Day whatever for being at home. Hope you're doing well. Hello there. It's good to see you guys. Nice to see the comments coming in. Let me, as usual, get myself set up and then we can chit-chat a bit. I'm starting to repeat myself every night. Take one night off and you kind of forget half of this stuff. We need to get back in the groove. I missed you. How's it going on your end? Hello there, Yaks. Miss Cough. Hello from Indianapolis. Nice to see you all. Yeah, I had a chance to watch the Liberty Gold replay, and I learned a few things. Saw many of the kind of technical comments. I appreciate you pointing things out. Main thing I learned was it's a directional microphone, so if this camera face is facing me, the microphone's pretty darn good. But Rob the gold miner was on the other side, of course, and I still need to look into how that goes. But yeah, I became clear after a while that his audio was not good. It wasn't on your end. It was just got a good mic on one side of the camera. So I got a couple emails from some of you helping me with ideas and how to knock down the wind noise and all sorts of things. And I appreciate it. I've been thinking ahead. I don't think I mentioned. Yeah, our programs begin at 6 o'clock p.m. So 7 minutes from now. Always do this just to check in with you all and also to test things out. I don't know. It's just me tonight. I don't know if we need to test anything out. Got a couple tricks up my sleeve as per usual. Yeah, I don't think I'm testing anything. So I'll take a stroll around the block. I'll be back in a bit. Just kidding. Psych. A friendly reminder that we'll be here again tomorrow night, which is Sunday, same time, 6 p.m. And really our talk, well, I'll save that for everybody at the top of the hour. Why the stream up since 103? Is it a play saver? Oh, I don't know if I understand that comment, but I was screwing around a little bit this afternoon with YouTube, trying to figure out how to set a time ahead of time. People are still getting confused and not finding us, and they wanted to join us live and they couldn't. And so, you know, I subscribe to a number of YouTube channels, and in my feed, sometimes I see that there's a kind of just a thumbnail in my feed, and it's, you know, scheduled next Wednesday at 7 p.m. Join Food Wishes or whatever. So I don't know if that's a good move or not. I guess that's the thing I'm experimenting on tonight. Maybe I'm asking you with a couple of quick back and forths. You know, I'm doing this to kind of share the schedule, and I'll probably keep doing it this way. But I also, do you think it would be helpful to have a little, or let me say it this way, do you have reminders or like something scheduled with YouTube video channels that you enjoy? To me, that's different than notifications. Yeah, hit the bell to be notified, but I think I'm talking about something else where it's literally a scheduled thing, almost like if you're on Facebook and there's this, you know, there's this thing called events, and so you just have a little thing that shows up on a Facebook feed, and it says event, and you can say you're going or you're interested, but anyway, it's all that kind of scheduling information. Anyway, I always want to make sure people know how to find us, and I think as we continue to do these, we're approaching 10 of these now. I guess people are kind of figuring it out, but I get the sense that many watch it in replay, not by choice, like they just couldn't find it or they forgot or whatever, and maybe it's not my job. I know it's not my job, but I feel like I want to be accommodating, especially if the interest is there. There was something else I wanted to say or ask. Forgot what it was. Yeah, so the notification thing, I'm kind of, I'm realizing on your end that's kind of your deal. And sure, would you mind, like we normally do? Prineville, thank you. Where are you coming from? I've been hearing from more and more other countries overseas where we're streaming live at 3 in the morning where they are, etc. So I'm actually starting to think about possibly changing the time that we stream these. Maybe next weekend as an experiment. Because I'm hearing from more and more folks who would like to join us live, but they're not that committed that they're going to set an alarm and be up at 2:30 in the morning, and I totally understand that. Great, Kentucky. Oh, that's the other thing I wanted to say. I still hear from, well, by the way, I'm getting tons of emails a day. I'm way behind on emails. It's nice to hear from all these folks. But if you're waiting for a reply from me for a question you have, I'm sorry, I'm just not getting there. I'll get there. I am hearing from a lot of folks that they still can't read your comments, whether it's live and see the comments scrolling, or I think it's a shock to some that you can watch a replay of this after the fact, like tomorrow morning, and still see the comments scrolling. And I think the comments are helpful for a number of reasons. So basically, if I'm talking about you and you just don't know how to find those comments, I'm sure somebody here in the next couple of minutes can help you out, but it's a little window on your right side underneath me talking to you right now, and it probably says top comments or top chat or something, and you can kind of click on that and open that little window up and even pop it out and make a separate little window. But my point is, even if it's a replay, you can see those comments, and that's part of the fun of this. I guess it depends on you. Maybe you don't want to see what everybody else is saying. All right, how we doing on time? 30 seconds. I gotta go get into makeup. I'll be back in 30 seconds. Makeup? Well, good evening from Ellensburg, Washington, USA. So glad that you're with us tonight. This is a geology live stream. You're hearing me right now talking into this phone, this iPhone 11, and it's going straight to you wherever you are around the world, and that is always exciting. I still can't get over that. Let's take advantage of this technology and talk about a topic tonight that is going to be a real change for us. We're going to have to make some adjustments mentally. One big adjustment is we have to be willing to go back hundreds of millions of years into our past if we're talking about supercontinents. And last I checked, I think that's what we're talking about tonight. So hundreds of millions, even billions of years ago, my Lord, how are we going to do that? I have a trick, might work for you. There's a couple other adjustments as well. You know that I live here in the Pacific Northwest in North America, and that means that I'm talking specifically about the states of Washington and Oregon, and tonight we'll be talking about Montana a little bit. But I will not be talking about the entire planet tonight equally. We'll do some global stuff initially, and then we'll get right down to the Pacific Northwest and look for evidence for more than one supercontinent. I think you'll enjoy it. And yes, there's a full hour Supercontinents and the Pacific Northwest lecture that I did last spring. I actually had to watch it this morning. I kind of forgot half of it. You don't normally teach this stuff, so I was taking notes this morning, like listening to this guy talking about supercontinents. So this is an abridged version. Why is it abridged? We've got an hour. Why don't I just give you the full lecture? Well, you know the answer. I can't show you visuals. I can't show you animations or pretty pictures or maps on a screen, but this is live and I can answer your questions in real time. And if you're new to us, a special welcome to you. Children, welcome to you. When we're done with the presentation in about a half an hour-ish, I'll let you know and then we'll do live Q&A. Okay, great, let's do it. So I got a couple of things with me. I ran up to school and grabbed this thing. Hope nobody misses it up there when they're scrambling to do their online stuff. Starting on April 8th here at CWU. So this is planet Earth, and it's a beautiful globe. You've seen a globe, right? You have different sizes of globes. Maybe there's one in your bedroom or in your study or something like that. This one is particularly nice, maybe too big for our purposes tonight, but what the heck, beggars can't be choosers. And how's your map reading here? So this is home to me, North America, and my backyard is right up here. Near Seattle, Washington. We're about 2 hours to the east of Seattle by car. And South America, of course. And this is the Atlantic Ocean. And here's Africa, and here's Europe. And one of our boys is in Beirut, Lebanon. Not able to leave. That's a story for another day. He's doing well. He's got a good spirit to him. And here's the Pacific Ocean. Okay, well, how can we get into this idea of supercontinents? Well, how many continents do we have today? Even Antarctica is a continent down at the South Pole. There's 7, right? 7 continents. We can name them. Okay, great, we got them. And there's oceans in between these continents. Especially for the children. Did you know that these continents are moving? And that the North American continent is actually moving west about 2 inches a year. The South American plate is moving west about 2 inches a year. I mean, these are averages. The African plate is moving east 2 inches a year. The Eurasian plate's moving east 2 inches a year. So basically, this Atlantic Ocean between Africa and South America, or Africa, Europe, and North America, the Atlantic Ocean grows in width by 4 inches every year. 4 inches every year to cross the Atlantic Ocean. 4 inches. That's pretty fast for us in geology. You can measure something every year, and you can see a noticeable difference on the scale of a couple of inches. So in general, on the planet today, the Atlantic Ocean continues to grow in width, and the ocean basin gets bigger and bigger every year. But we live on a ball. I don't know, do we have any flat earthers with us tonight? Probably not. But if we do, okay. So the Pacific Ocean is getting smaller and smaller every year. So during our short time on the planet, the Atlantic Ocean is growing and the Pacific Ocean is shrinking. And the Ring of Fire is showing us that there's subduction of the ocean plate and we're destroying the Pacific Ocean crust all the way around the margin. Okay, so let's get to the idea of a supercontinent. It's maybe what you're guessing, and I'm guessing you've heard of a name of one supercontinent that we know about. What's the name? Let me listen real close. What's the name of the supercontinent that you know? It's not North America. Right. It's Pangaea. It's Pangaea. That's the name of the supercontinent. And the supercontinent was literally this: one continent and one ocean on planet Earth. Pangaea. A supercontinent is just like it sounds. All of these pieces of land were hooked together, were connected. And maybe you're new to this if you're a student, a very young student. Here's a portion of South America that has kind of a knob to it like this. And here's an armpit of Africa that has the same shape. And we now know for sure that that part of Brazil tucked right into that part of Nigeria. We know that for sure. And in fact, we know all of these jigsaw puzzle pieces, that's the common analogy, used to fit together with one supercontinent. Okay, well that's a concept, and I'm guessing many of you know that concept. Think about that first of all, that for a long, long time, and we'll talk about timing in just a second, our planet had one continent and one big ocean. We actually had that for 100 million years. Pangaea was one supercontinent that lasted 100 million years. And only recently, in our time frame tonight, has Pangaea started to break apart into 7 pieces and opening the Atlantic Ocean. So we could do a whole thing on a guy who kind of proposed this idea. His name was Alfred Wegener, a German meteorologist, and he started presenting at scientific meetings in the 1910s, 1912, 1915, and he was a laughingstock. This guy's ridiculous. He's proposing Pangaea, and the fact that these continents are moving around, this is more than 100 years ago, everybody said this guy's crazy. And he doesn't have any evidence except that these little continental pieces look like they fit together. And Alfred didn't take that news very well. I don't know what his personality type was, but he essentially spent the rest of his life, from 1915 to 1930, traveling around the margins of the Atlantic Ocean, finding evidence that Pangaea was actually a thing. And he was finding, excuse me, he was finding certain kinds of rocks around the eastern margin of the Atlantic, and he was finding those same rocks around the western margin of the Atlantic. In other words, he was finding very specific kinds of rocks and geologic folds and fossils and glacial striations and anticlines and synclines and mountains themselves that didn't really make any sense with their current global position. But if you did this closing of the Atlantic Ocean and make Pangaea, it fit. All those clues fit together. And it's a sad story. Alfred died in 1930 in Greenland on one of his expeditions. And so it's always sad to report that someone was ahead of their time. Nobody agreed with what they were proposing in science. and they didn't live long enough to see that they are now hailed as a very bright, ahead of their time person. So Alfred Wegener, we salute you. You're no longer with us, but you came up with this idea of supercontinent, and I got to pick up the pace now to keep some of our advanced people motivated to join us tonight. We now know that there were at least 3 different supercontinents. Make a supercontinent, hold it together for a while, break it apart. Get the continents to have a different configuration, hook them together again. That's a supercontinent. Hold them together for hundreds of millions of years, then break that supercontinent apart. Then have another little party, get those guys back together. 3, at least 3. And as we go further back in time, our evidence for the details of the configuration of those older supercontinents is more and more sketchy. That's how history works in general, right? The further back we go, the less we know. That's coming. And we're also going to look for evidence here in the Pacific Northwest for more than Pangea. But I want to stay with the kids portion for just another second. Alfred had problems convincing people that these continents moved because everybody basically asked the same question in science 100 years ago. How do you physically explain how we can actually move this thing? This is a huge continent. How are you going to move a continent, Alfred? They asked. And everyone at the time, this is long before what we know as plate tectonics today. This is long before we knew about a tectonic plate. Everybody 100 years ago assumed that the ocean floors were flat and the ocean floors were the oldest part of the Earth. And so Alfred was proposing that this continent was moving and somehow plowing through or displacing or pushing like a snowplow through the ocean crust of the floor. And that was a physical problem that he couldn't explain. He actually tried, and that was a bad move because the physics and the math broke down immediately. So one way to view the Earth and to realize that we have actually moving pieces of crust, not just the continents, but we now know that the ocean floors are also moving. Alfred would have loved to know that 100 years ago. He didn't have that information at the time. Kids, have you seen this before? Kids, what's this? Yeah, it's a knife. Right, it's not very sharp, but it looks sharp. And this is a wooden handle. Chicago cutlery. Okay? Present from my parents 25 years ago. I've maybe sharpened it once since then. Okay. And kids, what's this? This is an apple. In fact, here's a familiar Washington sticker. Do you have these stickers in your grocery store? This one says Stemilt, USA, Fuji. It's a Fuji apple from Stemilt. That's up at Wenatchee. That's like an hour away. So our apples don't have to travel very far because they're grown right here. We have apple trees all over. No, okay. So I don't know if you've heard this before, but to really understand what portion of the interior of the Earth is moving, to allow these supercontinents to break apart and come together, we need to cut the apple in half. It's a dull knife. Hi-ya! Did not land on the laptop. Good. So this is an apple, and this is the core of the apple, just like the Earth has a core. And this meaty part that's oh so delicious, I can't hold it now, I gotta have some. Juicy. Washington apples. This episode brought to you by Washington apples. This is the mantle. Excuse me. This is the mantle of the Earth, this meaty part. And you can barely see, can't you? Let me come in. I've been practicing with my focus. Head out of the frame, hand up, focus on the hand, get the apple, slowly bring the apple in. So you can't really see the thickness of the skin, can you? The skin, of course, is here. But look at this. You can barely get into that skin. And what I want to tell you is, these continents moving around and getting together as supercontinents are basically, can I do this? Not really. The Earth is like an apple with individual pieces of its skin broken into pieces, and then, I wish I could do this, I wish I could hit a button and do it, have each of these little pieces of apple skin move in a different direction. And we don't think there's a lot of movement in the mantle, but we don't really know. We know there's not much movement in the core except for the outer core, the liquid outer core that's got some sort of gyration thing going on. But we know for sure that these individual sections of the surface of the Earth, called tectonic plates, are moving. And Alfred didn't know about plates, but he knew he had all the evidence in the world for continental drift. So basically, continental drift is an old idea because it was talking about moving continents, assuming that the ocean floors were dead and lifeless. We now know that it's more than continents that are moving. There's these things called tectonic plates, was a portion of a continent and a portion of an ocean floor moving together. Let me show you a map. We're about to go to supercontinents for the rest of tonight. But here's a map that you may have seen, unless you took geology. Are you an old timer? Did you take geology at Washington State in 1961? If you didn't, you haven't seen a map like this. You haven't seen, well, I know you've seen stuff since, but back in that college classroom, look at all these red lines out in the middle of the oceans. Each of those is a plate boundary. And we need to think of these tectonic plates. Like that whole thing is a tectonic plate. This whole thing is a tectonic plate. A tectonic plate almost always has some ocean floor and some continental crust on it. And the key concept we need for tonight is that the ocean floor continues to get recycled. The ocean crust is created and destroyed over the course of a couple of 100 million years. But these continental portions, they stick around for thousands of millions of years. So we're creating and destroying the ocean crust, but the continents are just these giant bumper cars that continue to cruise around with the sparks flying in the upper part. We'll come back to that map. Okay, so kids, I hope you've got a feel for it. We're going to raise it up a couple notches now. Okay, here we go. This is the crux of tonight. We were just talking about Pangea, and we know from Alfred's work and from some work that we've done on the ocean floors and a bunch of work in the last 50 years involving ages of fossils, ages of folds, ages of basalt on the Atlantic Ocean floor in a weird symmetrical pattern. We know that Pangea was assembled, put together, those continents were put together to form Pangea 300 million years ago, and Pangea started to break apart 200 million years ago. Here's the 100 million year span that I was talking about, where we had one continent and one ocean. So I'm guessing that's familiar to most everybody. I'm guessing for most of you, these two older supercontinents are brand new. Or if they're not brand new, you don't know much about them. I barely know much about them. But this particular supercontinent called Columbia actually has a lasting legacy in the mountains of Montana. And I'll explain in just a second. So just to further explain this, if we go before Pangea, we had a different global geography. Who knows how many continents we had? Actually, Christopher Scotese does. If you want to YouTube, don't go now, please. But if you want to go to a YouTube channel that is outstanding, Christopher Scotese has spent a whole lifetime as a geologist making animations of continental positions through time, and he makes animations beautifully. Scotese, I think, is S-C-O-T-E-S-E. Christopher Scotese. You'll find him. YouTube animations, continental drift animations, whatever. He's got like 24 of these things, and they're set to classical music, and they're beautiful. So he can show us Rodinia, which is the supercontinent before Pangea, totally different global arrangement, totally different position on the planet, assembled 1,100, so what are we doing here? 1,000 million years is equal to 1 billion years. So this is 1.1 billion years ago, or we can just keep it in millions for our sake tonight and say 1,100 million years. That sounds so weird, doesn't it? And then started to break apart 750 million years ago. And then supercontinent Columbia, sometimes called Nunya, was assembled at this date and split apart at this date. So if you're a math person and saying, this doesn't, this stayed together for 400 million years and this one only 100, like what's up? Well, as we go back further in time, our dates, muffler boy! As we get older, these dates get wonkier, not as precise. And so this is kind of where we are currently with our understanding. I want to ask some specific questions for this. The main question is, on this map here in the Pacific Northwest, here's my backyard, Washington, Oregon, Idaho, Montana, Wyoming, where can we find rocks that are old enough, number one, that are actually from this time? I mean, is that even possible? Do we really have rocks that are 1,000 million years old? The answer is yes, and even older. But where do we go? And how does Washington, many of us have a specific interest in Washington, how does Washington fit into this? Well, I'll answer that one right now. Washington's not part of any of this. Even when Pangaea is starting to break apart 200 million years ago, there is no Washington. In fact, let's do that. Let me use this chalkboard right now. And I got something else on the whiteboard. I'm getting excited now. I'm kind of a slow ramp, but I'm there now. Can I draw the west coast of North America on the chalkboard 200 million years ago? The answer is yes. Can I do that? Yes. Can we see how much of Washington we have when Pangaea starts to break apart? Do you have a guess? Apple's dirty now. Why did I do that? I wanted to... Fat white chalk, electric company chalk, dating myself. There, I did it. What did I do? What is this? This line was the west coast of North America, in this area, for hundreds of millions of years. Was the west coast, near Spokane, Washington, John Stockton's house, beachfront property. I'm saying that my backyard was not here. Everything here on the west of our shoreline was deep ocean. I'm not saying it was just covered with shallow water or lakes or something. I'm saying it was deep, deep ocean, not even a hint of a continent. And you're like, well, that's interesting. Tell me how did we make all this crust in the last 200 million years? That's tomorrow night. Tomorrow night is exotic terrains and something called Baja, BC, which is going to blow your mind. Even if you've heard of it, we'll have a discussion that's a little bit out there. But if you've never heard of Baja, BC, please tune in tomorrow night, Sunday night, 6 o'clock. But back to the story. We know that this is the old shoreline, and specifically, in places, not everywhere, but in places in this shadowed area, we have rocks that are old enough to go all the way back to supercontinent Columbia. Let me repeat. There are some Precambrian rocks in the mountains of Montana, in northern Idaho, even north of Spokane. So we did have a teeny tiny slice of Washington for a long time. But that old shoreline then drops down towards Boise. It heads down to Vegas eventually and down to Mexico. And this sharp boundary also goes up along the spine of the Rockies. This is long before the Rockies and everything else. But what I'm saying is, in just a bit, we're going to go to this map and I'm going to be very specific about where you can go. Maybe you've been there and you didn't know the significance of those rocks. that are helping us not only see that supercontinent Columbia was a thing here in the Pacific Northwest, but there's even a little bit more to the story. But before we do that, I have one more whiteboard I want to show you, and it's weird. Just warning you. It's odd. I had an idea about an hour ago, sitting out here in the backyard. It's a self-portrait. What is this? This is my corny attempt using my body to make sure we can get things straight. It's like I'm having a heart-to-heart talk with you now. You've screwed up somehow, and I'm trying to talk some sense into you. I need to change the tone. You haven't done anything wrong. You've done everything right. In the last 11 days, you've done everything exactly right. Congratulations. All right. What I'm trying to do here is take some of our earlier live streams and compare it to this geologic timescale and realize that our topic tonight and our ideas tonight cannot be mixed up with all these other stories. You know, geology is just a bunch of stories. To me, that's the best way to communicate geology. Sure, we got to be careful with the science and the evidence and data versus interpretations, but it's all just about stories. The stories have to be based on the field evidence, in other words, but it's story time. And I think, especially as I do more and more with people and groups and online lectures, it's common for people to mix up the stories and assume that all the stories are happening kind of at the same time. And it's an easy thing to do. And will this dorky idea work? Probably not, but let's try it anyway. What have I done? I can't even remember. You still need to see it. So I've taken the geologic time scale. Here's the Precambrian era, ends at 570 million years ago. Here's the Paleozoic era, ends at 251 million years ago. Here's the Mesozoic, the age of the dinosaurs, ends at 66 million years ago. And then everything up here is the Cenozoic time period. What's in blue? Dates in millions of years of stuff we've talked about in my backyard in the last couple of weeks. 300 to 200 million years ago. That's Pangaea, the youngest of the supercontinents. All right, the train. We hear you. You're crossing. Yeah, you're crossing over there on... okay. So our most recent Pangaea... Oh, God, do we need it? Our most recent supercontinent is down at my knees on this geologic timescale. Do you see what I'm trying to do? And if we go back to Rodinia and even supercontinent Columbia, we're down in my feet. We're down in the soles of my shoes, bro. We're way down there. And just to flesh this out, my belt is at the extinction of the dinosaurs. The palm fossils a couple nights ago in the Squawk Formation, that was last time actually, 56 million years ago, the PETM hot. My chest is the Teanaway basalt and the Ellensburg blue agates and the Liberty gold. My chin, we're almost to the top of my head. We're almost up here to you and I doing a live stream in my backyard at the very top of my head. That's present day. The chin is the Columbia River basalts, the German chocolate cake. Like, just missed my mouth. German chocolate cake on my chin. Stupid. And then up at the top of this hair that's getting longer and longer every day and no barber in sight for the next month, less than 1 million years. That's the Ice Age. That's the Ice Age floods. So maybe we'll continue this if we feel like we like it and it's helpful. But the attempt, I think you see, is what I'm trying to do. We need to realize that there's different parts of this body, different parts of this geologic time scale, and almost all of these live streams will be above the belt. Okay. It's time. Oh, Lord, it's 6:30. Are you kidding me? Okay, perfect. 10 minutes. It's time to look at the evidence very specifically here in the Pacific Northwest. Do we have a name for all of these rocks in this white shaded area? All we know so far is that they're forming kind of inland of the actual coast. So these are beach rocks. I'll give it to you verbally. The two main kinds of rocks in this area, I don't know, have you ever been to Montana and found slate or argillite? Those are metamorphic rocks. Slate and argillite are metamorphic rocks that used to be shale. And shale used to be mud. In this case, the shale, which now is the argillite and the slate, used to be tidal muds. Used to be mud at the beach in a tidal zone where we have sea level rising and falling, and we're depositing all of this quiet clay in the quiet waters along a beach front. And there's stuff in those rocks that tell us for sure it was the beach. You know what mud cracks are? Where the mud is drying and wetting and drying and wetting every day if you're in a tidal zone. Well, there's beach rocks that have those petrified into their rocks. There's current ripples in these beach rocks in this area. I haven't told you the time yet, haven't given you the name of the unit. You might know. If you're really kind of smart-ass little commenter, you've already kind of jumped the gun. Way to go. Good job. You're on point. There's also quartzites. Quartzites all through this area that are Precambrian in age. Who cares? Well, the quartzites, metamorphic, used to be sandstones, sedimentary. And before the sandstones, they were grains of sand at the beach. So the quartzite is representing the sand of the old beach, again, for hundreds of millions of years. And the argillite and the slate is representing mud at the beach. Okay, so what do we call these beach rocks? And where can we find them? Collectively, these beach rocks are called the Belt Series, named after the Belt Mountains in Montana. If you've heard of the Belt Supergroup or the Belt Series, these are these Precambrian rocks that formed at the beach. And that's something I knew for a long time and would teach occasionally. Glacier National Park is a very famous place to see beautiful exposures of the belt because the glaciers have dug so deeply up there along the going to the Sun Highway, for instance. But the belt reaches into northeastern Washington. The belt continues down through central Idaho, etc. So you can find these rocks, again, along this margin. And what's this again? This is the boundary. So this is deep ocean. And we've got these belt rocks as our evidence. Okay, well, that only gets us a certain part, doesn't it? That doesn't really promise or follow through on the promise that I had. What was my promise? My promise I was going to show you some evidence before we quit the chalkboard and we turn over to you. I wanted to show you evidence that we actually had a supercontinent here. So what am I even saying? I'm saying that there's some details that we have found in the belt. And by the way, the belt is a series of these rocks that are still pretty flat. So it's almost like a German chocolate cake, but we need another name. I don't know. What's another kind of cake? Angel food? Angel food cake that's 5 miles thick. Remember our German chocolate cake was 3? We need a 5-mile thick cake to represent this belt. And the dates, I have to look it up actually. Let's see what my notes say from this morning. The belt can you read that? Maybe not. This 5-mile thick angel food cake known as the belt was deposited between 1.5 billion and 1.4 billion years ago. Or, as I've written it, 1,500 million to 1,400 million. 1,500 to 1,400 million. So was the belt, those beach rocks, were those rocks deposited during Pangea time? Of course not. I'm telling you, that cake was made during those dates, and Pangea is just a glimmer in somebody's eye. Even Rodinia is too young for the timing of when we're depositing these rocks at a beach. And you're like, I still don't see how this fits into this story. All you're telling me is that these are beach rocks. And I'm with you, you're right. But we're going to do it right now. This is the last part, and it's right where I want it to be. We now have the ability to study individual grains of a mineral called zircon. You've heard me talk about zircon before. It's a revolutionary technique that has blown the doors open on so many intellectual questions over the last 20, 30 years. I mean, I was in grad school 35 years ago, nobody was talking about zircons. And now it's on everybody's tongue. Because you can take an individual zircon and figure out where that individual grain of sand came from. Think of that. You can go to your favorite beach, you can paw through all that quartz sand, and you can find not a quartz sand, but a zircon. It's a different mineral, zircon, which is a very hard, durable mineral that has this amazing ability to record information. And you can look very carefully. I know my map's going away. We can look very carefully at that zircon, and we can figure out where it came from. Okay, I'm going to go right to it. So you would assume, wouldn't you, that most of the sand in the belt, the beach rocks, came from the interior? What I'm showing you are arrows, are rivers flowing from east to west, east to west. We can assume that in the most simple case, can't we? If we got a bunch of sand at the beach, that sand is broken down bedrock from the interior of old North America. And that's true. A majority of this sand at this beach during this time came from the interior of North America. But here's the fun part. We've finally arrived. Some of the zircons that have been collected in the belt are not from North America. They got the wrong chemistry. They got the wrong source rock. In other words, you can find some sand grains and you can't match them with anything east. And it's not just zircons, by the way. There's also something called crossbeds, where there's layers, kind of swooshy-like layers in a sandstone, and now a quartzite, that can show you the direction that the river was flowing. By studying crossbeds in a sandstone, now a quartzite, you can determine, like a detective, oh, there was a river here and the river was flowing south, or the river was flowing southeast, by measuring the orientation of those crossbeds. Do you see where I'm heading here? There are many, many zircons. I'll use yellow. Many, many zircons in the quartzites and sandstones of the belt and crossbeds that clearly tell us that there were rivers flowing from west to east at this time. Pause for dramatic effect. You can't have rivers coming out of the ocean floor. We know how rivers work. Rivers come from mountains. Rivers come from places that are higher, and the rivers flow downhill. Yet we definitely have a bunch of sand that was brought in by rivers that came from the west. How do we solve this? A bunch of Montana geologists 30 years ago came up with a way to describe this. Don Winston in particular is the godfather of this. Don Winston, even in the 1970s, is saying, and drawing maps and saying, there was a continent here. During this time, 1,500 to 1,400 million years ago, there was a continent that was parked and docked right here at John Stockton's house, right at Spokane. And when that continent was here, there were rivers flowing from that continent X. He didn't know which continent it was. He just called it continent X. He knew about plate tectonics, but he didn't know enough detail about other continents that we have today to know who was here. But somebody was definitely here because of the crossbeds and the exotic zircons that are found in the belt. It's 2020, that's the year, and we still have a disagreement. Most geologists that I've read think that this was Australia. Are you watching from Australia? You used to be right here. Instead of my backyard, it was your backyard, parked right here. But not everybody agrees it's Australia. Basically, this is a game of finding rocks that are this old, bedrock, in Australia or in Antarctica. I'm not making this up now. Or in South China. Those are the candidates. 3 different continents that may or may not have been here during which supercontinent? Use your dates now. Somebody was here. Let's call it Australia. That's the majority right now. Australia. Australia was here during which supercontinent? During this one. The last 100 million years of supercontinent Columbia, we had rivers from Australia bringing zircons to Montana and Idaho. And by the way, if you're suspicious, they got some of our stuff too. When you find the belt, essentially in Australia, you're finding sands that came from us. It's amazing stuff. Let's finish the story and then we'll go to you. So we have the belt when supercontinent Columbia was in existence. Supercontinent Columbia started to break up at 1400 million years ago. It's unclear if Australia rifted away a little bit and then came back, or Australia just hooked onto us and stayed with us during a breakup of the rest of supercontinent Columbia. And I'm saying that because once we get past the belt time, this is advanced thinking now. Kids, I hope you're still with us, but whatever. I'm trying to reach everybody. We know that Australia left us for good 750 million years ago. There's some rocks called the Windermere Group. They're greenstones, metamorphic greenstones today, but they were originally basalts. When you rift a continent away from another continent, you open up fractures and you have a bunch of ocean basalts coming to the surface. So we have 750 million year old basalts that are now greenstones that tell us when Rodinia started to break apart. And there's formations like the Pritchard Formation and other parts of the belt that help us, or a little younger, that help us with the timing of that breakup of Rodinia. So, we're coming to your questions. I'm getting longer and longer every night, aren't I? This is 6:45 now. But, we're not going to the geology of Washington or Ellensburg or Seattle. All that stuff's too young. All these topics that are coming, even the topic tomorrow, will be above the belt. We're way down here with a completely different global arrangement, multiple times. And this is just a little taste of all the global evidence that we have of different years to reconstruct these continents together. It's a great topic that I know very little about, but at least know how we can tie it into the Pacific Northwest. Thank you for the attention. We've got a little beautiful sun coming down right before it slips over the ridge. And it's time for you. Why did I look into the sun? Now I can't even see the screen. So uppercase, if you're new to us, you want to ask a question, type in uppercase. We may be all over the map now with this topic, but I'll do my best. All over the map. And I'll try my best. I'm going to scroll back and find some angel food too spongy. Okay, that's more of a comment, really. What is the average density of the belt series part of the North American continent? I don't know what the average density is. I'm sorry, but it is a unique, thick package of remarkably flat-lying rocks. I mean, they're so old, and yet they haven't been folded. And there's reasons for that, but it's, again, if you Google some beautiful shots of some steep, Mount Gould or something in Glacier National Park, and you'll see it looks just like the rocks were brought in yesterday and deposited. But density, I'm sorry, I don't know. Somebody else is asking about, same person. Yeah, density is not my thing, sorry. How are quartzite and the others formed? Basically by burial. So if you remember, I mentioned that quartzite used to be sand, and sand used to be at the beach. I'm sorry, quartzite used to be sandstone, and then sandstone used to, oh, we can do that, what the heck. So let's do a quick little sketch to show how you go from sand and mud to argillite and quartzite. Okay? Let's make the let's have the river come from Australia. This is a cross section. Okay? So here's the surface. People are walking around 1,400 million years ago, whatever. Okay. So we're going to deposit the sand by the river. You with me? And we can do some mud too. Here's some mud in some kind of lagoon. Okay, well, that's a Tuesday. And then Wednesday, we're going to bring in more sand and more mud. And Thursday. And every day of every year, of every century, of every millennia, we're just going to keep bringing in sand and mud. And so the stuff that was there yesterday is going to get buried, because we keep loading the surface with more and more sand and mud. Oh, beautiful light now. This is the golden hour. And eventually, you're going to take our sand and bury it between 1 and 3 kilometers depth and get sandstone, which is a sedimentary rock. It's no longer loose sand, it's now a sandstone. It's glued together. And we'll take the clay, the mud basically, and make a sedimentary rock called shale. But is the belt series sandstone and shale? It's not. What is it? It's quartzite and slate and argillite, which is slightly different, but it's basically the same stuff. So we just bury these guys deeper yet. So it gets hotter and more pressurized deeper down. And that's my answer there. Dramatic effect level, okay, thank you. Mind blown, more of a comment. May I moderate for you? No, I think we're okay, thank you though. Didn't they find rocks from Australia and vice versa? Yes. What were the longitude and latitude of the supercontinents? I was trying to figure out how I could show you an animation on my laptop, and that may actually work at some point. But I couldn't drive it. It went too slowly. So again, it's easiest for me with this discussion just to visualize an east-west kind of a motion, that's simplest for us. But there's lots of different vectors of motion, and we've got supercontinents that are all glommed in the northern hemisphere and the southern hemisphere and straddling the equator, etc. And that's not guesswork. That's all been carefully reconstructed by many geologists, but the gift of this Christopher Scotese, Scotese, YouTube channel, you'll see it. And you can freeze it and try to figure out things like that. That's the best answer I have for you there. What side of Australia was connected to North America? I should know that, and I don't. I'm sorry. I don't know how Australia was positioned at that time. We can't assume it's the northeast coast today. That would be too easy. I should know that, and I don't. My apologies. What evidence says Australia left? Why do I lost your question. I need to go to a YouTube tutorial on frickin' scrolling on a laptop. Why is this such a problem? Can't find it, sorry. Would a supercontinent have an effect on the stability wobble of Earth's rotation? It's a common question, and I don't know. People who are in kind of the geophysical field, I think, have done some calculations on this sort of thing, but I don't know if there's consensus on that. Crappy answer, but I don't know. What evidence says, there it is, here it is, I found it, Bruce. What evidence says Australia left the Pacific Northwest rather than the other way around? Yeah, I'm just saying it that way. There was a rift. There were normal faults, basalt, all of the telltale indicators of two continents rifting away. Similarly to North America rifting away from Africa 200 million years ago when Pangea started to break apart. So, you know, it's semantics, I guess. I don't mean to say Australia had the Evinrude in the back of their boat and they just started pulling away. It's just the way I've described it. What time in history do you most wish you could visit to find out about your geology stories? Well, interesting question. I don't usually dabble in the feet. Because we're so far down there in the feet, in the Precambrian, and we have so little evidence, and there's so much mystery that I kind of lose interest, I have to admit. So I like the recent stuff. Chest and higher. A lot more evidence, closer to present day, less guessing. Was the Juan de Fuca plate formed as Australia drifted away? No, Helen. The Juan de Fuca plate, which is the current ocean plate we have diving offshore, all the ocean plates we know about are from the chest up. And so if we're way back more than 1,000 million years ago, we have no way of knowing which ocean plates existed where because they're completely gone. So I mentioned earlier that these ocean plates are recycled, truly. And there isn't one piece of ocean floor on the planet today that's older than like 400 million or something like that. How long did it take to get the continents to go halfway around the Earth and meet back up 600 million years ago? I don't have an easy way to answer that. I guess you can do some math. 2 inches a year. Where was Craters of the Moon on Pangaea, Rodinia, and Columbia? Ha ha! Inside jokes now. If you're new to us, people ask about Craters of the Moon every night after I shouted into the camera at one point, like, I have to do something about Craters of the Moon. People are just so interested in that topic. I watched a Scotese animation today where you can see Australia and North America connected. And depending on which animation you look at, if you find some other ones on YouTube from other authors, they'll have Antarctica next to us, or China, or, you know. So, like I say, it's not a done deal. What method did they age the rocks in the Belt Series to gain such precise ages of 1,400 to 1,500 million years? Do rocks get better with time like lasagna? I can't give you a specific age dating process, David, but we can be clever about how we sample and get ages. Some of it's from this, maybe the best answer is the zircons themselves. If you go into the detail of a zircon, the zircon has growth rings. It's almost like a jawbreaker. And the outer rim of the zircon has a younger age than the inside. And there's some chemistry there that I don't understand and some physics there that I don't understand. But you can get these different ages even out of one zircon, and that's a whole nother angle that I'm not prepared to talk about tonight. But that's one example of how you can be quite precise about not only the age of the original bedrock, but there's other ways to figure out where you are in that cake. And I agree, angel food's a dumb analogy. I froze, I couldn't come up with another cake. I'm sure there's 4 other cake suggestions here. And I don't know, should I go to Vinman's Bakery and ask for a whatever, marble cake? How does Steptoe View fit into this timeline? Steptoe Butte has belt. I lost my map. Steptoe Butte is south of Spokane, north of Pullman. Thank you, Carlson family. And Steptoe Butte is a mountaintop that kept its chin up above the flood basalts. The German chocolate cake did not bury the quartzite of Steptoe Butte. Steptoe Butte is part of our beach that we're talking about. You can drive right to the top and, I don't know, is it a state park? It's not, is it? Can you take a sample from the top of Steptoe Butte? Why not? Bad role model for the kids. Was the rest of Washington still the same shape even when it was deep within the ocean under the other continent? Well, Evelyn, thank you for your question. You're so good with your questions. I really regret erasing my map. I'm not trying to say that the continent went underneath another continent or under the ocean. I want you to think, I just want you to think of puzzle pieces. And here's your jigsaw puzzle, and you're pulling two pieces apart on your table that you're working on, and then you're kind of locking them together and then bringing them apart. And yes, that line that I drew, which was the coastline for a long time. And at least one big jigsaw puzzle came in Australia and fit nicely. And a better way to say it is, when Australia finally broke away, that crack, the shape of that crack is the crack that we know as the old shoreline. It's amazingly well defined in the subsurface. How old are the rocks in Washington and Oregon? There's a lot of different ages, all the way from our story tonight down at the feet, up to rocks that are forming in the crater of Mount St. Helens in the last 10 years. Is it true that the Appalachians are the oldest mountains on the planet? No, they're not the oldest mountains on the planet because that's one way. There's many different kinds of evidence to prove that a supercontinent existed. Remember how we started tonight and I talked about how that guy went around the margin of the Atlantic Ocean to find mountains that used to be together? Like here, the Appalachians here, and here's a continuation of the Appalachians in Norway. Muffler boy! Here's another part of the Appalachians, which is in Morocco. And the Appalachians are definitely older than the Rocky Mountains. And we can see that. In fact, we think the Appalachians used to be as big as the Rocky Mountains. But the Appalachians have been wearing away because they haven't been building in the last 200 million years since Pangea started to break apart. But we have evidence of mountains that formed when Rodinia was put together, and Columbia when it was put together, those supercontinents. And they're not mountains anymore, but they're the roots of mountains. Really fun to get your questions tonight. Is Quartzite, Arizona part of the Belt Series? It might be, I don't know, but that would be my guess. I don't know Arizona geology well enough to answer it specifically. Is the New Madrid Rift part of the Pangea story? I struggle with the New Madrid Rift. It's a failed rift. We're talking about a place down where the Mississippi River is today, and there's evidence of basalt coming up through that about, well, actually, hang on. Here's an organic thought as we're talking. The mid-continent rift, where basalt actually came up, where the Mississippi is flowing, is this age right here. Now, why would you have a rift at Duluth, Minnesota when Rodinia is being put together? That doesn't make any sense to me. But it doesn't fit into these other stories. 1.1 billion or 1,100 million. But again, we're out of Washington, so I don't know how much work has been done on the Mid-Continent Rift recently. A couple more. Why is geography important today? Well, I don't know, because I'm in geology. But if you mean geology, there's a need for scientists around the world. I don't want to elaborate, but there's a strong need for careful science work and careful communication of science work. And so the fact that we're asking a question like that, why is science important, is maybe the best way to say where we are currently in our society. Are the Precambrian rocks in Nevada part of the same ancient coastline? Probably, but again, I'm sorry, I don't know. I lose it once I leave Boise, basically. And there's been so much rifting of Nevada in the last 20 million years, it's hard to follow that line. What drives continents to break apart and what determines where they break? We don't know that, Mary. So you remember my apple, and we're going to finish with a toast by chewing into some apples tonight from Washington. We know for sure how many tectonic plates we have. We know for sure which directions they're moving today. We have a good idea of what directions they moved tens of millions of years ago. We still don't know what is driving these plates. And you're like, well, hold on now. I've read it's convection in the mantle. I'm not sure we know that. Or the evidence is compelling, but I don't know enough geophysics to really understand the data. Maybe it's B. The New River is one of the oldest rivers. That's true, Andy, a.k.a. Wikipedia. Are we going to dock for the next, where are we going to dock for the next supercontinent? Let's finish with that. So it's like Christopher asked me to plug his YouTube video, or YouTube videos, which he didn't ask me. I don't even know him. But he has some animations looking into the future as well, which of course is taking our present projections and just assuming those directions will continue. That's all we can do, just like our curves that we're reading in the newspaper every day about what's going on in the next few weeks. But it's safe to say, I think, that we will continue in the next 100 million years to open the Atlantic. We will continue to close the Pacific. And you tell me, where do you think we're heading if we continue to drift to the southwest and Australia continues to go north and the Eurasian continues to go east? And will that be a complete supercontinent or a partial? Many of these things are difficult to put together. Oh, why not? Two more. Would the erratic granite rocks in the northwest from Montana originally be from Rodinia? No. Granites are typically belt high, Mesozoic, and chest high, Eocene. And the granites are from subduction of some ocean plates and some other things from ocean plates that we know now. So at least in the northwest, the granites are not part of the Precambrian story. They're definitely not part of the belt story. Please recommend one or two good books for my 11 and 9-year-old boys, big geology fans. Well, that's an easy one. Especially here in the Pacific Northwest, there are roadside geology books. And you're like, yeah, okay, I know about those. Yeah, it was like 35 years ago. They got yellow covers. Well, I'm not talking about those. There are some excellent second editions of roadside geology books for almost every state now. In the case of Washington and Oregon, Marley Miller has put together a beautiful book. And it's not just driving down the road and pulling off at mile marker 111 to see a little detail. She is a gifted photographer and a gifted map maker. She has some of this Rodinia stuff in the book, for instance. She has stuff from much of what we've been talking about in this backyard series. So I think those roadside books, especially the second edition, Rob Thomas just came out with a new one like this month for Roadside Geology of Montana. I'm talking about the belt and that sort of stuff. So it's got new data, much more visually stimulating and interesting things, and that's what I typically recommend. Otherwise, for a person under the age of 12, books, boy, that's a tough one. I'd say the roadside geology books would be a place to go, and you could plan a little field trip. And as a parent, even if you don't know much geology, you can read ahead and put a little 3-day trip together, let's say, and you know ahead of time where to stop the car and what rocks to look for. And because of Marley's gift or these other authors' gift, there's a new roadside book from British Columbia. There's one for Nevada, Northern California, Southern California. There's a Geology Underfoot series. Dave Tucker did one for Western Washington. So that's the style that I prefer. I'm kind of doing a audio and visual version of roadside books in my mind. And if you like this kind of level, then that's probably for you. A toast for you tonight. And a reminder that tomorrow night we're going to take these concepts of especially breaking up Pangaea 200 million years ago, and we're really going to try to figure out how Washington was built in a simple way, which is satisfying to all, and then with Baja, BC, a more complicated and an intoxicatingly complex set of ideas that more and more of us are very excited about. But it's a toast for you. My God, we've been at it a while. Look, we've got a browning apple already. Let's get rid of that. Here's to your health, the health of all your parents and grandparents, the health of your children and grandchildren, nephews, and that favorite uncle that you have. And here's to the health of all of us, all around the world, together talking about geology. Amen. See you tomorrow night. Thanks for joining us tonight. Love you.